Hello, everyone. Welcome back to the robotic classes. My name is André Dias, and I'm from Portugal, from Academia de Robotica. Today, we're going to explain and explore with you the analog signals that you can acquire with Arduino. In particular, we're going to explore two sensors, the LDR and the TMP36. This video is supported by the Erasmus Project Discovery Robotics via STEM. For starting, let me describe what are the main goals for today. First, we're going to understand what is one analog signal and a digital signal. There are differences, and we're going to explain what is the main advantage of having sensors that provide us analog signals. Then we're going to explore two analog sensors. One is the LDR sensor, and the other the TPM36. One is able to read the light, the value of light in the room, and the other, the temperature. And then we're going to have two challengers, one for reading the LDR and display the information, and another to show the temperature of a room. And then we're going to provide, as a homework, a challenger that you can do by yourself and then share with us. List of material that you need to have for today: the microcontroller Arduino, the breadboard, the LDR sensor, the TMP36, two LEDs, red and green, two resistance and of 330 ohms, and one resistance of 10K. And also, don't forget to have the block software for developing the code and the integration with Arduino. For starting, let me explain what is the main difference between a digital sensor and an analog sensor. As you can see, I provide here an example that is a tank. And the tank can be full or empty of water. If you check here in your left, you have here a digital sensor, that is this sensor, that is able to tell us if we have water or if we don't have water in the tank. But sometimes we need to have more information. It's not enough for us to have if I have water or if the tank is empty. I need to know the level of water that is inside of the tank. And the digital sensor is not able to provide us that information. The only thing that is able to provide is, if it's empty, it says 0, provide us 0 output. If it is full, it provides us 5 volts output, level 1, high, state high. But with analog sensor, we are able to have a measure, a value between 0 and 5 volts, and that value between 0 and 5 volts will be proportional to the level of water that we have inside of the tank. So it's easy to conclude that with analog sensor, we have the possibility to have more information about the state of something that we are measuring, like the water level. And with the digital sensor, we just only have one state, 0 or 1, low and high, that in some situation like this example that I'm providing here is not enough to know what's happening inside of the tank. So how can we use analog sensors? In Arduino, we have 6 pins that are able to work as analog input. That are the pins that are identified with A0 to A5. So you have 6 pins that you can connect sensors to that pins in order to measure the analog signal that a sensor is provided to you. Some analog examples that you can have to use integrated with Arduino. Today we're going to explore 2 of them, the temperature sensor that is here and also the LDR sensor. Another example is like this potentiometer, where we can change and slide the position for different positions, and we have as input a value that is going to change between 0 and 5 volts, and that value will be proportional to the real value that the sensor is measuring in the wall. In case of the digital sensor, we have here some examples. As I can see, I can have a button like the previous video that we have provided to you, or something like this that is a switch where we can press, and by pressing the switch can switch from 0 to 1, like the bottom, but with this supporter that allow us to have contact point. Okay. Let's start by the LDR. LDR means light dependence resistor. It's a sensor that will provide a resistance as an will variate this resistance, and consequently will variate this voltage that with that voltage we're going to acquire in the analog input. As you can see here, if you have daylight, the value will be 500 ohms. If we have dark light, the resistance will increase to 200k ohms. Okay, so it is a photoresistance sensor that, based in the value of intensity of light that we have in one room or in the place where we are using, we're going to be able to acquire a value that will be a voltage correlated with the intensity of light that we have in the room. So what is the main transformation that we're going to have by using the pins, the analog input pins? As you can see here, you have 6 analog pins available in the Arduino, and we're going to give to the Arduino a value between 0 and 5 volts that is going to be provided by the sensor. The sensor provides that information, and the analog, the Arduino, the analog pin, is going to convert the value to a digital value between 0 and 1023. This means that 0 will equivalent to 0 and 5 volts will be equivalent to 1023. Okay? So for starting, let's start by assembling this circuit. This circuit is composed by the LDR sensor, a resistance, and we have here a circuit where we're going to measure the intermediate value between the LDR and this resistance. This means that in this middle, we're going to have a voltage that will be proportional to the intensity of light that the LDR is going to measure. So for starting, let's assemble this circuit in our breadboard. So we're going to switch here to the breadboard, and let's start doing this assembly. For starting, we're going to put the LDR sensor, this here. Okay. In the same way that we saw here. We're going to put a resistance of 10K between this point and G and G to make sure that we have the negative value available in this line. We're going to connect the negative value. Okay. We're going to connect the 5 volts to the 5 volts. We need to provide on top of the LDR the 5 volts. And the medium value here, we're going to connect to the analog input 0. Okay. And now, let's discuss what type of instructions that we can use to implement. Back again to the slide here. What we have here. This is the circuit that we already have assembled, and what we need to do. The M block provides us one instruction, one block that is called read analog pin. And here we can define which analog pin that we want to use. In this case, we want to use analog pin 0. At the same time, I'm already creating a variable that I'm going to call analog input, and this variable will be responsible for storing the analog value that I'm going to acquire from the pin, okay? And then we are using also a serial write text to make sure that we are able to see the value that the analog put is provided. I'm going to switch again to the M block here and going to start implementing the code that we were discussing. If you have any doubt, please feel free to go back in the video and check again what were the instructions that we were considering. We're going to create a variable, as I said, that I'm going to call analog input. The name can be the name that you wish to use. We're going to use here the forever block, create the set analog input, and now provide here the instruction read analog input from, and here define that we want to read the analog 0. After, you want to provide the output with serial write text, and to make sure that we are able to read the information, I'm going to add here a delay in order to make sure that we are able to change the value and see the impact. So next step, connect and upload to Arduino. We complete the upload. And now, to make sure that we are able to see the serial write text, we need to connect again. You're going to start seeing here in your shell the message. We need to change to share mode. And then you are seeing that we are receiving 942. And now, if I start changing the light by putting my hand in top of the sensor, you are seeing that the volume is decreasing. Okay. If I take my hand, the volume is increasing. So in robotics, what we could do with this type of sensor? This type of sensor is used in domotic to control, for example, the light of a room. So with this information, I'm able to say what type of light I have in my room and variate that value. We could make sure that if the light is lower than what we is expecting, we can, for example, turn on one light. Okay, if the light intensity is smaller, we can increase this value by having an external light that turns on when this value is smaller. Okay. Back again to the code. Okay. This was the instruction that we do. So we read the analog pin 0, store the information inside of this variable, and we show the result. Okay. This was one example of one analog sensor. Now we're going to explore another analog sensor. This analog sensor is the temperature sensor, the TPM36, that is able to measure temperatures from -40 degrees to 125 degrees. Okay? And to do that, it has 3 pins. It has the power supply pin, this one. It has the pin here that is our analog output will be in this pin that we're going to have a value between 0 and 5 volts that will be proportional to a value between -440 to plus 125 degrees. So the tension, the voltage that is going to have in the output here will be proportional to this value that you are seeing here. Okay. So it's the same principle that we saw before. We're going to have a sensor that is able to provide us a voltage between 0 and 5 volts, proportional to this between minus 40 to plus 125, and is going to provide us as output a digital value here. And then we need to convert that digital value that we have here in a temperature in degrees Celsius. To do that, it was important to check what we call the TPM36 datasheet. Datasheet is a term that is used for accessing a file. In that file, there is the specification of the sensor or specification of the component that we are using. Normally, the datasheet has this information: what is the power supply, what is the current that the sensor will consume, what is the range, what is the accuracy of the sensor, what is the scale, what is the type of package. The type of package is a 3-pin TO92. This is this type of package that you are seeing in the right. Okay, 3 pins with the socket TO92, this package that you are seeing here. And also, the datasheet provides us this equation that says that the value that you're going to receive, okay, multiply with this constant minus 0.5 multiplied by 100 is going to be the equation that allows us to have the output in degrees Celsius. So the value that you're going to have, the digital value, you need to convert by doing this equation in M block in order to, in the end, we have an output that is equal to the temperature in degrees Celsius. Now that we already know how to convert the value from the analog to digital and then the digital to degrees Celsius, the next step is to perform the assembling of the TPM36. As you can see here in the figure, there are some constraints that you may consider. For example, you need to assemble the sensor with the information in front of you to make sure that the pin 1, that is the power supply, is the number 1, and the pin number 3 in your right is the GNG of the pin. Normally is one of the mistakes that the students done. Normally they don't check if they are assembling in the correct way, and if the sensor start becoming too much hot, this means that it was assembled in the wrong way. So please be careful and make sure that when you have the label in front of you with the reference TPM36, you know that in the left you have the power supply, V+, and in the right you have the GNG. So let's start assembling this, and then we back again to discuss the code. So for starting, as I was mentioned, be careful and make sure that the sensor is assembling the correct way. In this case, we are putting in the left the pin positive and in the right the pin negative. In the right, the pin negative. Connect the power supply to the breadboard. Don't forget to do this step. And now we're going to connect the analog output from the sensor to the analog input from the Arduino pin A0. Okay, it's here, assembled here. Okay, back again to the code. Let's discuss what we have to do. So, if you remember that what we have done in with the LDR sensor, we need to use the block read analog pin and provide us the pin that we are using. In this case, we are using the same A0. We need to create 2 variables. One variable that will be responsible for the digital value, to acquiring the digital value, and another that will be responsible to have the temperature in degrees Celsius. If you remember, we need to perform this equation. The digital volume multiplied with this constant minus 0.5 multiplied by 100. And this equation will allow us to convert the digital volume in degrees Celsius. Okay, let's implement this in mBlock. So, created variables, digital volume, temperature, and now Arduino program, loop forever, set digital pin, set digital volume equal to analog pin 0, and then we need to do the operation. For starting, my suggestion is to starting from left to the right. So the first operation is multiply the digital value by 0.004887586, and then perform minus 0.5, and then multiply by 100. Okay, and make sure that this is equal to this. Okay. In order to check if everything is okay, we're going to include here the serial write tags to receive the result of the equation. And to make sure that we have time to see the result, I'm going to include here a delayed 0.5 seconds. Okay. Connect to Arduino and upload. As you remember, when you upload the code, the Arduino disconnects. So to see the value, you need to connect again. And now we are receiving that the temperature in the room that I'm inside is with 19 degrees. To check if it is working, I'm going to put my hand on top of the sensor to see if the temperature increases. My hand is more hot, so the temperature is increasing. When I take my hand, the temperature starts decreasing, and slowly will converge to the value that we will have before, that is the room temperature. Okay. Back again to the slides. So this was the code that we performed. And with this code, we are able to have the temperature available. And with this temperature, we can do some things like this homework that I'm going to leave for you. So the idea is the following, is to implement 3 LEDs, 1 red LED, 1 green, and the yellow. And what I want you to do is the following. If the temperature is higher than 24 degrees, we want that the red LED becomes enable. If the temperature is between 18 and 28 degrees, we want to have the green color LED enable and the other 2 disable. If the temperature is below 18, this means that room is cold. We want to have the yellow color turn on. Okay, this is the challenge for you. If you have any doubt, feel free to send me an email or ask me any help by using the YouTube questions that is available for that. Okay, I hope everyone enjoy, and see you next time for more adventures with robotics. Bye.